So what I'm saying is based on the design model, we also predict a nested hierarchy. You don't like the example of modes of transportation, but based on design, so human design, and we're created in God's image, we're going to look at modes of transportation and conclude that, wow, that, would be a very good inference as to
We're
how
in
God may
God's
have
image,
decided
and
on genome.
it's
Because the
just
really
that
thing
isn't.
God's a shitty programmer. But sorry, my bad.
If anything else, the intelligent design shows more how anything else is designed than humans or other organisms.
all
I
I'm
mean,
saying
look,
Different conversation.
all I'm saying with my point, and you can, like it or lump it, and the audience can decide, is I'm just saying that the invention of crossover vehicles, I don't know if you know what those are, Google Dodge Journey, Ford Flex, for example, the distinction between cars and SUVs is becoming blurred. And what is currently labeled a car and what is labeled an SUV is now a matter of debate. So human engineers have designed and are still designing transitional forms. That's why I say traits are inherited, bones are not. When we look at the genetic level, we're seeing a genome that has a trajectory of genome-wide functionality. We're seeing
Right.
loss of information, genetic information limits. This is more consistent with a biblical-based model and design. Go ahead.
So do you understand the purpose of the fossil record as to how it pertains to evolution?
Oh, how does a fossil form to begin with, since you've said fossil so many times?
Sure, fossils tend to form by rapid burial, but they can form by other means as well.
Like what other means, for example?
I'm not about to go into the laundry list, but I'll just list the most common example, which once again is rapid burial.
Okay, so I would say that the vast majority of fossils were from the global flood. And hear me out. There is evidence that the Earth was once underwater. I mean, we see marine fossils on mountains and in landlocked areas far from the sea. We'll probably agree with that. Some sedimentary rock layers extend over entire continents or even further. And the thing is, the deposition of those layers had to have been catastrophic, or else there would not have been much fossilization. I mean, you just admitted that these fossils are formed through rapid burial. Let me ask you a question. How many animals do you believe died today? Just today?
Today, I don't know, probably somewhere in the hundreds of thousands. I don't know.
I would say even more like millions, but even hundreds of thousands. How many of those do you believe fossilized?
Probably not very many, considering the means by which most organisms actually die.
Exactly. So for somebody with that basic assumption that the Bible is true and a global flood must have happened, the evidence is overwhelming. I mean, there are fossils of animals giving birth. I mean, think about that. Fish being eaten, suggesting sudden and rapid burial. But here's the most important part if you want an observation, and then you can continue. Look at Mount St. Helens. What did that demonstrate? It demonstrated that sedimentary layers, hundreds of feet thick, could be laid down in hours to days. Canyons can be formed rapidly. It can explain how multiple fossilized forests, and I suggest looking this up, could form as the result of a single volcanic eruption. And possibly, and this is what I find cool, how coal seams could be produced quickly. There's so much evidence in accord with the flood of Noah that you admitting that fossils are formed through rapid burial, I mean, that only helps my case even more. Go ahead.
Sure. I mean, you can also make sense of it by observing the fact that volcanic eruptions, other seismic events like earthquakes and other things that I'm not thinking of at the moment, produce the same kinds of effects that also will cause organisms to undergo rapid burial to have what we would call fossils. And
Well,
here's actually an experiment we can test for to see if the global flood is true, right? And so that experiment is with trees, dendrochronology. So the idea fundamentally is that the rings on a tree, fundamentally based upon that year or whatever particular way we do it, generally it's by the year that tree was in that environment, we can test whether or not, we can see rather, what the water levels are like. We can see, was it a dry season? Was it a wet season? Was it salty? Was the water more basic? Was it more acidic? Things like that. So, interestingly enough, we've done experiments with trees. We've taken samples of tree rings, cut a tree open, look at the rings from all over the world, grant you. And we see that there are certain observations within the rings. We can date and try and approximate how far exactly that these things happen. But what we don't find is a universal event where all trees share more or less the same particular trend for a particular season or for a particular time span. We don't see an instance of what you would call a global flood, because if it were, trees that exist and that have existed for some thousands of years would show these traits.
Well, see, the thing is, you're basing a lot of that on some assumptions that obviously a global flood hasn't happened and that rates have remained constant.
No,
As a matter of fact, some trees do produce multiple rings, but what I mean, and I understand what you're saying, but I just want to say one more thing, and then we will comment on that. Everything that I said prior to what you just said, I think is strong evidence for rapid burial based on a global flood. But even if we look at a genetic level, creationists and evolutionists, they do agree we were all descended from 3 women. Okay, so, and correct me if I'm wrong, I don't want to straw man you, but evolutionists believe these women were not the only ones alive at the time, right? But many more were around, and they definitely don't believe that these were the 3 daughter-in-laws of Noah. But creationists, we believe that these 3 women were indeed the daughters-in-law of Noah. So we actually
they were primates.
Well, we actually call this the LMN out of Africa scenario. But you see how that incredibly close this fact is with a literal interpretation of Genesis. I mean, we can track that back through mitochondrial DNA and actually see that evidence not only in, say, the fossil record, but even on a genetic level. And back to your tree rings, isn't, like, if we look at radioactive elements, okay, you would say that would prove probably that there was no global flood and that, you know, the Earth is, you know, billions of years old. But wouldn't that also be based on assumptions, right? Such as, you know, no daughter element present in the rock.
Daughter element. What?
Well, let me provide an analogy, right? So let me provide an analogy to kind of explain this whole thing about your assumption, right? So let's assume that, for the sake of argument, I'm cooking a meal and that I want to somehow classify or quantify, rather, or map out, or whatever you want to say it, however you want to phrase it. But I want to map out particularly how heat, so how when I heat the pan, how the distribution of heat goes through that pan over a specific period of time, right? And there's going to be some kind of model that dictates or that tries to govern how this behavior occurs. And, well, the interesting thing is, in the case of radioactive decay and daughter isotopes, I grant you, I'm not a nuclear physicist, but my understanding of it is that when you have, for instance, a radioactive element that that is gradually decaying, that is undergoing beta emission and releasing other kinds of particles that are, being let out over certain amounts of time, that it takes so long for a particle to release a daughter isotope, for a daughter isotope to actually be formed and present. And that, based on that assumption, even if there are, 1 or 2 daughter isotopes that are found, it's relatively insignificant because in practice you're dealing with isotope samples that are in the billions and jillions.
Okay, so let's break this down then. Okay, obviously for ourselves and the audience, because obviously we're both not, like you admitted, I'm not an expert on this either, but I seen Athena kind of blurt out daughter element as if he thought it was absurd. Like, let's look at a radioactive element. Okay, so let's break it down.
No, hang on. It's just that I never heard of that term. You know what I mean? That's why I was like,
I believe it's
heard of it.
Daughter isotope, but I'm not quite certain on that.
Okay. So let's say we got a radioactive element. Okay, we would call that a parent, which would transform or decay over time into a non-radioactive element called a daughter. That's all I meant. Whether it's a daughter isotope, but let's say, for example, uranium to lead. Okay, this would happen with a characteristic rate, which we would obviously call a half-life. Obviously we're simplifying this, but that would technically be the length of time it would take the parent element to transform into an equal amount of the daughter element, right? So over time, the amount of a parent element in the rock, it decreases, and the amount of the daughter isotope in the rock increases. So the point is, we're not measuring the ages, we're actually measuring the amount of isotopes present in the rock. So the age is not actually measured directly. So if the Earth is only a few thousand years old, even trace elements, like you're saying, just trace elements alone of the daughter element will increase and provide inaccurate answers of even, you know, up to billions of years old based on those initial assumptions. And the fact that we predict that because of the fountains of the great deep breaking open and the Earth cracked like an egg, right? Like an eggshell. The catastrophic consequences of that would be detrimental. And I feel like what we see, you know, in geology is perfectly described based on that. Would you agree with my assessment there of radioactive decay? Go ahead.
So fundamentally, radioactive decay is a measurement of when I have some concentration. Well, when I have some amount of an element, and it is decaying into a daughter isotope, which may be radioactive. I'm not sure if that occurs. It might, but for sake of simplicity, if it decays into a normal element, what is being measured is typically the decay rate or the half-life sometimes of that molecule. So what is measured experimentally and what seems to be consistent through measurements that we've made using theories in nuclear physics is that it takes a specific amount of time for some element, like uranium, for instance. Let's say it takes, I don't know, 2 million years for the massive uranium, you know, whatever the radioactive form of uranium is, to reach half of its initial mass. And that this can only occur over certain amounts of time. And so far, measurements have been consistent with that. So when we're seeing, for instance, like, oh, look, we only find, you know, such and such percent mass of an isotope. Well, we know that certain decay rates produce these atoms, and that it would take so long for these particular atoms to be released by this radioactive element. So the measurement of isotopes would tell us about how long it would take for this radioactive element to release these products.
Okay, so and I understand what you're saying, but in regards to our basic assumption, I mean, for one, contamination is common, okay? Secondly, since there are not actually conclusive starting dates, say for the radioactive decay, the age it's going to start with is really just, like I said before, an assumption or a guess. And most importantly, according to our model of catastrophic plate tectonics, that would increase decay rates. But a big thing would obviously be contamination. And
sure. I mean, the thing is that, so from my understanding of it, is that radioactive elements tend to only react with certain things to accelerate decay processes. The issue with that would be that, as far as I'm aware, as far as papers that people have told me about, is that radioactive isotopes tend to be in relatively isolated environments. They tend to be left to their own devices and irradiate. Fundamentally, though, the assumption you're raising issue with, obviously neither of us are nuclear physicists, so we can't pin down the assumptions of nuclear physics. But so far, I mean, nobody really rejects any assumptions that nuclear physics makes up to the point until we start judging the age of a fossil or something like that.
Okay, and according to catastrophic plate tectonics, you know, that rate would have increased by heating and from much material, say from inside the Earth, that came out, because we do know that exposure to heat or cold can change rates. But the coolest thing about it is, in just a second, the coolest thing about catastrophic plate tectonics and the model we've derived is there are falsifiable predictions. For example, the pre-flood ocean For example, the ocean crust. Okay, so based on the fountains of the great deep breaking open, much like I said before of an egg cracking, like a shell, it was dragged down into the mantle. Okay, this process is called subduction. Okay. The cold ocean crust, then, okay, here's the prediction. It should still be cold, obviously, if you're following, since this occurred only thousands of years ago, according to our model. I understand you don't believe the Earth is thousands of years old, but even though it has descended into the deep, hot mantle. Now, you can look at this as well. I can provide the website. It's based on a secular website, actually. Seismic data from NASA has actually revealed enormous slabs of cool rock under North America. Okay, so down in the core itself, which should be warm, okay, according to your evolutionary assumptions and theory, but confirmation actually of flood geology, which is quite cool. And we see the after effects of these plate tectonics. I mean, we see all the fault lines. Obviously, none of them are my fault, but we see the plates are moving. We see, I mean, such rapid evidence, and I think we've. How do you feel about that? Go ahead.
So the one thing that I have read is that, yes, that the decay rates of certain radioactive isotopes can change, except for it doesn't really make too much of a difference, because the rate at which they vary, for instance, so, you know, let's say uranium takes 200 million years in order to decay into lead, for instance.
Oh God, that's funny.
The rate at which the variation to which this can occur, based upon extreme heating or based upon exposure to some kind of high energy electromagnetic field, is at most plus or minus 20, plus or minus, 1,000 years, which isn't that horrible, because we're dealing with a time span of millions of years that an organism could have occurred in.
Yeah, I just